All right, let's dive in. Today, we're talking about one of the most fundamental shifts happening in AI. You see, if you spent the last few years mastering MLOps for traditional machine learning, well, get ready. Because large language models, or LLMs, they haven't just moved the goalposts. It feels like they've invented a completely new sport, and today we're going to break down the new playbook.
And this question, it really cuts right to the chase, doesn't it? All those robust pipelines you've built are fantastic for models that predict a number or classify a photo. But what do you do when your AI can generate fluent, convincing, and sometimes, well, completely made-up text? That single massive challenge is exactly why we needed a whole new discipline, LLMOps.
Okay, so just to make sure we're all on the same page, let's do a super quick refresh on MLOps. It's basically the set of rules and tools we use to build, deploy, and maintain our machine learning systems. Think of it like the perfect, well-oiled factory floor for models that spit out a number, a label, a simple prediction. It's structured, it's predictable, and honestly, we've gotten really, really good at it. And then, these things showed up. The big, powerful, large language models arrived, and they changed literally everything. You gotta understand, these aren't just a slightly different type of model. They are a fundamentally different kind of beast. They didn't just bend the MLOps rulebook, they pretty much tore it to shreds. Let's look at exactly how they did it.
So first off, just look at what comes out of them. A traditional model might give you a 7 or a simple yes or no. An LLM, it can write a marketing email, a Shakespearean sonnet, or a chunk of Python code. The output is fluid, it's creative, and get this, it's non-deterministic. I mean, you can ask it the same thing twice and get two totally different, totally valid answers. How do you even test for that? Second, how we talk to them is completely different. In the old MLOps world, we were obsessed with feature engineering, carefully grooming our spreadsheets and databases to feed the model. With LLMs, the main way you control it is through a prompt. It's less about wrangling data and more about the art of conversation, about crafting the perfect instruction to get what you want.
And then there's the big one, the one everyone talks about, hallucinations. An LLM can state something that is just flat out wrong with all the confidence of a seasoned expert. Your old regression model would never just make up a sales number, right? This one behavior alone means we have to build completely new systems just to fact-check the AI and keep it grounded in reality. And finally, the risks are just on another level. Because these models are masters of language, they can be tricked into leaking sensitive data they were trained on, where they can be attacked with prompt injections, which is basically like a hacker whispering a secret command into the AI's ear to make it ignore its safety rules. The stakes are just so much higher.
Okay, so that's the why. We've got these new wild challenges. So how does it actually change what we do day to day? Let's get practical and break down the key differences between the old MLOps world and this new LLMOps reality. So let's start with data, and this is fascinating because the very idea of what data is gets turned on its head. In MLOps, we live and breathe structured data. Spreadsheets, databases, you know the drill. In LLOps, our raw material is just text, PDFs, Word docs, websites, and the main job isn't feature engineering, it's something called chunking and embedding. We break the text into small pieces, or chunks, and then create these numerical fingerprints, embeddings, that capture the meaning of that text. And it's not just the data, the entire lifecycle gets a complete makeover. We almost never train a huge LLM from scratch. That costs millions and millions of dollars. Instead, we do what's called fine-tuning, where we just tweak a pre-existing model with our own data. And when we deploy, we're not just shipping a simple API anymore. We're deploying these complex conversational agents, often using a system called RAG, that's Retrieval Augmented Generation. We'll talk more about that in a sec. And this, right here, might be the single biggest mind shift of them all. With MLOps, success is a number. We can measure accuracy, precision, and recall down to the 5th decimal place. It's objective. But with LLMOps, how do you measure if a summary is good? Suddenly we're asking these fuzzy, qualitative questions. Is the answer relevant? Is it coherent? Is the tone right? Is it safe? So to try and get a handle on this fuzzy new world, we've had to invent a whole new toolbox of metrics. We've got things like blue and rouge scores that compare an AI's summary to a human's. We have ways to measure semantic similarity. But look at the last two on this list, hallucination rate and human evaluation. At the end of the day, after all the fancy math, you still need a human in the loop to just say, yep, that's good, or nope, that's nonsense. And it comes with all this new fancy tech, right? A massive price tag. We're not talking about a few standard GPUs anymore. We're talking about huge clusters of the most powerful high-end GPUs or TPUs. And because of those embeddings we talked about, we need brand new kinds of databases called vector DBs to handle them. Every single one of those is a new line on your cloud bill, which is why LLM costs aren't just a little higher. We're talking a whole different stratosphere of cost.
Okay, so we've officially torn up the old playbook. What does the new one actually look like? What are the steps you need to follow to do this right? Let's walk through the modern LLMOps workflow. This is it. This is the modern game plan. And notice where it starts. Step 1 isn't data prep. It's prompt engineering, crafting that perfect instruction. Then you bring in your own data for reg. You might do some optional fine-tuning, then you deploy. But you're not done. You have to constantly monitor it, not just for bugs, but for cost, for weird behavior, for latency, all while managing it and making it better over time. I really want to zoom in on RAG for a second, because it is absolutely core to making these things useful in the real world. This is the magic that lets you build a chatbot that can answer questions about your company's private internal documents. The process involves indexing all those docs, creating those embedding vectors, and then for every single question you ask, it intelligently finds or retrieves the most relevant bits of info and gives them to the LLM as context. And the other piece of this that is just, you cannot skip it, is safety and moderation. This is a massive part of LLMOps. It means building filters to catch toxic language. It means actively trying to reduce the model's biases. And it means putting up guardrails. Sometimes these are even other AI models, like LlamaGuard, that act like a bouncer for your main AI, checking everything that goes in and everything that comes out to make sure it's safe. So when you step back and look at all of this together, you realize we're not just talking about swapping out a few tools or learning a new library. This is a fundamental shift in philosophy. It's a whole new way of thinking about what it means to manage artificial intelligence. And this table really brings it all home. The goal of MLOps was predictable model deployment. The goal of LMLOps is managing a scalable, safe intelligence. Model behavior goes from deterministic to, well, creative and unpredictable. Evaluation goes from hard metrics to soft, human judgment. And even the tools of the trade change, from classics like MLfloat to entirely new frameworks like LangChain. Look, if there is one single idea you take away from all this, let it be this one. MLOps manages models. LLOps manages intelligence. MLOps was about keeping a predictable machine running on the factory floor. LLOps is about being the responsible steward of a powerful, dynamic, and sometimes unpredictable intelligence. It's about steering it, keeping it safe, and making sure it's helpful and accurate. So really, this whole journey from MLOps to LLOps is the story of AI growing up. It's moving from being a simple prediction machine to being a complex reasoning engine. And yeah, it's harder, it's more expensive, and it's way riskier. But it also unlocks a universe of things we could only dream of building before. Which brings us to the big, exciting question. Now that we have the playbook to manage this new kind of intelligence, what incredible things are we all going to build with it?